Hello and welcome to my channel. In this channel, we explain various nursing concepts in a simple form for a better and easy understanding. These videos could be used by both LPN and RN students as well as nurses who are trying to refresh their basic concepts. My name is Nasmosh. In this video, we are going to talk about the introduction of the GI system as well as the labs that we need to know with the GI system. So the GI system, also known as the digestive system, consists of a long digestive tract or alimentary canal and associative organs. These organs are liver, gallbladder, and pancreas. So whenever we talk about the digestive system or the gastrointestinal system, these organs are part of that system. The digestive tract starts from the mouth and ends in the anus. Digestion of food starts in the mouth with the teeth chopping, cutting, and grinding the food into smaller particles, while the salivary glands produces saliva, which contains digestive enzymes that begins to chemically break down food. Digestion of starches starts in the mouth, right? So with starches, amylase, which is in the saliva, helps chemically break down the starches. So saliva not only has digestive enzyme properties, it's also used as a lubricant to make chewing and swallowing easier of the food, right? So the tongue helps push the food down during swallowing, and the food goes down the esophagus, right? That's why when you have something like a cleft palate or a tongue twist, swallowing is a problem, really. So the food travels into the stomach where HCl, also known as hydrochloric acid, is produced. Hydrochloric acid has properties like it kills harmful microorganisms in that food that you swallowed, and it also produces pepsin enzyme, which initiates the breakdown of proteins as well as peristalsis. So, and peristalsis is actually the movement of your intestines, right? And with peristalsis, this mixes the food, resulting to a chyme, right? Remember we were talking about food particles. Now when the food gets into the stomach, it's now referred to as chyme. Chyme is pushed down into the small intestines, and the small intestines has three sections. We have the duodenum, the duodenum, and the ileum. So when it's pushed down to the small intestines, digestion continues in the small intestines and nutrient absorption is initiated in the small intestines, okay? The liquid food, which is chyme, is moved into the large intestine through what? Peristalsis. So the way food moves in the GI tract is through the mode of peristalsis, right? So, and in the large intestines, we have the colon, the rectum, and the cecum. So in the colon, this is where water, sodium, and chloride are reabsorbed from the liquid chyme, right? And this turns the chyme into a semi-solid form, which is known as the feces. So these feces are pushed out to the rectum. That's the end product of your digestive system. So they are pushed to the colon, right? They are in the colon. So the colon has 4 layers, and the mucosal layer secretes mucus, which lubricates the passage of the feces. Okay, so the food digestion starts in the mouth, absorption starts in your small intestines, and finally reabsorption of the water, sodium, and chloride happens in your large intestines. So labs. Some GI labs that we need to know are, so the AST and the ALT levels, the range is normally between 0 to 35. So if these values are elevated, this is an indication of the liver dysfunction. Amylase and lipase. So with amylase, we normally see the value is normally under 220, and with lipase the level is under 160. If lipase and amylase are elevated, it will be indicative of pancreatitis. And remember, amylase is sugar, right? Lipase is fats. Bilirubin. The range of bilirubin is 0 to 1, and if it's elevated, it could be indicative of either a liver dysfunction or bile duct obstruction. Albumin. Albumin range is 3.5 to 5. You could remember albumin levels the same as potassium, right? 3.5 to 5. If albumin levels are elevated, it could be indicative of liver dysfunction or nutrition. And also remember, albumin has association with volume expansion, right? And also protein synthesis. Ammonia. Ammonia ranges between 10 to 80, and when these levels are elevated, it could be indicative of the liver dysfunction. Thank you for watching. Please like, share, and subscribe to my channel. See you on the next one. Bye.